Hi everybody. So this is the second part of our lesson for today. This is the lesson for 4.1b. We've defined the terms sign diagrams, zeros, and multiplicities. And so now what we're going to do is we're going to use sign diagrams to sketch some polynomials. And our essential question is, how do I use zeros and sign diagrams and multiplicities to sketch the graphs of polynomials? So you would make sure that you're seeing your critical terms page, critical terms for definitions of these three terms here. I'm going to highlight them, sign diagrams, zeros, and multiplicities. So you're going to see your sign diagrams for that. Here are the steps that we'll pass through. We will first find the zeros by factoring in one of three ways. We can factor, if that's possible, by using the square root properties. Okay, and so square root property just means, like, so if I have something like x squared minus 2 equals 0, I don't really need to factor that. I could do x squared equals 2 and then take the square root, and that's using the square root property, plus minus the square root of 2. Also, I do want to mention that I can actually factor that, because that's the difference of perfect squares. And I know you don't think that 2 is a perfect square, but it is a perfect square if I take its square root. It's x minus the square root of 2 times x plus the square root of 2. So anytime you have this format, x squared minus some number c, you can factor it difference of squares. Because it's a subtraction, you can factor it. It will be x minus the square root of c times x plus the square root of c. So if you wanted to factor it, you could. Or you can use the square root property if that's what you prefer. Number 2, after you find your zeros, however you're going to find them, you're going to create your sign diagram to find when your f of x or your y's are greater than 0, when are you above, and when your f of x's are below the x-axis, when you go above the x-axis, when you go below. And then 3, you're going to sketch the sketch the polynomial, and then you definitely want to watch for multiplicities. Watch for large multiplicities, because remember, the larger the exponent, the flatter the graph will get as you near the 0. So watch for large multiplicities. Okay, so there's that. All right, so here we have 3 examples, and we're going to buzz through these. So find all the values for x such that your y is greater than 0, you're above the x-axis, and when you're below the x-axis. Sketch the graph of the given polynomial function. So here we have our first equation. All right, our first function. This is a cubic function. All right, first of all, I want you to note that this is the y-intercept. And how do I know it's the y-intercept? Because if I plug in 0 for x, that's my y-intercept. And 1/4 times 0 cubed is 0. 0 minus 2 is negative 2. So that's always useful to find out. All right, so I'm going to go ahead and find my zeros. To find my zeros, I have to make my y equal 0. So 0 is equal to 1/4 x cubed minus 2. So I think in this case I would use the cubed root property to solve this for x, because that's what I'm looking for. So I'm going to add 2. So that's 2 equals 1/4 x cubed. And then I think we'll just clear the fraction, right? We just multiply both sides times 4. And so we get 8 equals 1x cubed. We'll just call it x cubed. And so now we'll use the cube root property. The cubed root of 8, you don't have to plus minus this, because this is a perfect cube. Then 8 is a perfect cube. It's 2 times 2 times 2. It's not negative 2 times negative 2 times negative 2. So we're going to use the cubed root of 8 and the cubed root of x cubed, so we can cancel that out. So x equals 2 is our 0. So we have a point at 2, 0. That is our 0. All right. And so what we're going to do now is we're going to use our sign diagram, and our x is at 2. So right here, if we were to plug in a 2, we would get 0. And here's our equation. 1/4 of x cubed minus 2 is our equation. So if I were to plug in, for example, 0, I know that if I plug in a 0 here, that's going to produce a negative. At x equals 2, our y is equal to 0. So if I were to plug in, say, a 2, a 4. Okay, so I'm doing 1/4 of 4 cubed. Well, that's 1/4 of 64. That's a huge number. 1/4 of 64. 64 divided by 4. What is 64 divided by 4? 1? Okay, it's 16. 16 minus 2 is positive. Okay, so there we go. We have our sign diagram all figured out. Basically what happens, if the coefficient of your x term is positive, then you have your 0, and to the left of 0, when your coefficient's positive, will be negative, and to the right of 0, your outputs will be negative. So here you are below the x-axis. Here you're at 0, and here you are above the x-axis. So if I were to draw this with the critical points that I know, here's what I know. It's got a multiplicity of 3 here, so that means that it's going to get kind of flat near our 0, and our 0 was at 2, and our y-intercept is negative 2. That's what I know. So I know that this graph is coming from negative infinity, because until I get to x equals 2, I'm below, so it's going to do something like this, and then I'm going to get to 2, and then my graph is going to go above. And so that's a sketch. There you go. That's all you got to do is just sketch it. It says sketch. And then we have to find all our values for f of x. So f of x is greater than 0 in the interval between 2 and infinity, and our f of x is less than 0 from negative infinity to 2. Right? That's what our table, our sign diagram told us. So there's that one. All right, let's go to this next one here. So here we have a quartic function, but notice that it's in trinomial in its form, and this term, this exponent, is double that exponent. It would kind of be like doing x squared minus 12x. Notice that those exponents, this one is double that one, plus 27. I can factor those just like if I were factoring, I can factor the x to the 4th minus 12x squared. So I'm going to use the AC method. So we're going to do 1 times 27 is 27, and adding to negative 12. So the terms we're looking for here are 9, negative 9, and negative 3. Negative 9 times negative 3 is positive 27, and negative 12. So we're going to do x to the 4th minus 9x squared minus 3x squared plus 27. That's just taking our 12x squared and splitting it in half, equals 0. And then we're, of course, going to factor the front and factor the back, right? So in the front, hang on a second. So in the front, they have a common factor of x squared, and that leaves us with x squared minus 9. And in the back, their common factor is negative 3. So we're taking the negative 3 out of there, and that leaves us with x squared minus 9, because negative 3 times negative 9 is positive 27. And so here's what we have. X squared minus 3 times x squared minus 9. And if you recall, I taught you how to factor both of those. So we're going to set both of those quantities equal to 0. So x squared minus 3. Well, let's go ahead and factor that. We can go ahead and factor that. Remember what I told you. You can factor it if it's a difference. That's x minus the square root of 3, x plus the square root of 3. So that's that factored. And then this is the difference of squares, x minus 3, x plus 3. All right, so those are going to be our zeros. So what are our zeros? X is equal to plus and minus the square root of 3 and plus and minus 3. Those are the zeros for our 4 terms. And it has 4 zeros. Typically they have 3 or 4 zeros. The largest exponent is 4, so it could have up to 4 zeros. Also, let's just note that our y-intercept, if we plug in 0 for x, would be 27. Okay, so here are our zeros. So if I were doing my sign diagram, I would put negative here, negative 3 here, and then negative square root of 3 here, and then the square root of 3 here, and 3 here. All right, so those are all our zeros. So we know that our graph is going to have zeros there. Now we're going to take all our factored forms, x minus the square root of 3. Its 0 is the positive square root of 3, right? Because positive square root of 3 minus the square root of 3 is 0. And because the coefficient of our x is positive 1, to the left of that 0 it'll be negative, and to the right of that 0 will be positive. We'll take x plus the square root of 3. What zeroes that out is negative square root of 3. So that's the 0 for that one. And then that's a lead coefficient of positive 1 on your x. So to the left of the 0 is negative, and to the right of the 0 is positive. This is a great tool, sign diagram. All right, then we have x minus 3. Its 0 is positive 3, and since that's a positive 1x, to the left of 0 is negative, and to the right of 0 is positive. That's how number lines work. And then on the last one, we have x plus 3. That's our last set of factors there. Its 0 is negative 3, and to the left of 0 is negative, and to the right of 0 is positive. All right, so there's our sign diagram. Now listen, we're multiplying all of these numbers together. That's multiplication. So you're going to multiply negative times negative times negative times negative. All I ever do is count how many negatives there are. If there's an even number of negatives, then it's a positive. If there's an odd number of negatives, then it's a negative. So here we have negative times negative times negative times positive. That's negative. And then negative times negative, that's positive. And then one negative, that's negative. And then all positive, that's positive. So this means we're going to be above. This means below. This means above, right? This is below. And then this is above. So when we go to sketch our graph, this is telling us what side of the x-axis we're going to be on if our zeros, and where was our y-intercept? It was way up at 27. Okay, so I'm going to just put 27 way up here. That was our y-intercept. And then we have a negative 3 and negative square root of 3 and positive square root of 3 and 3. There are our zeros. And then we're just going to look. To the left of negative 3, we're at positive values. So this graph is going to come down. And then between negative 3 and the square root of negative 3, we're below. And then we're back above. So we're going to pass through our y-intercept there. Between negative square root of 3 and positive square root of 3, we're above the x-axis. And then we go to x equals negative, or square root of 3, and then we're at 0, then we're below. And then we come back up to 3, and then we go above. And so that's a sketch of your graph. So the f of x is greater than 0 when our x's are in the interval from negative infinity to negative 3. That's this interval, and this interval, and this interval. So union between negative square root of 3 and square root of 3, union 3 to infinity. Those are all above. Those are when our y's are above. Here, our y's will be below in these two intervals here. So between negative 3 and negative square root of 3, union square root of 3 and 3. Notice I keep those intervals open because the 0, we don't want to include the zeros because there's no equal sign on our inequalities. And so there you go. And again, you could plug that into Desmos to check to make sure you've got a good graph and you used your sign chart well. This last one here is nice because it's already factored out, but I do want you to put you on alert for that because that's got a negative coefficient on your x that's going to flip on your sign diagram. Also, we have some multiplicities here. So this one has a multiplicity of 2 and a multiplicity of 2. Okay, that means that the graph is going to bounce off of those zeros. It's supposed to bounce off the zeros. So the 0 for this would be x equals 0. That's a 0. And x equals positive 3. And x equals negative 4. And be careful here. 2 minus x equals 0. We'll add x. So x equals 2. So that is your, those are your zeros, right? You're just looking for what number zeros those out, right? 0 squared, and 3 minus 3 is 0, and negative 4 plus 4 is 0, and 2 minus 2 is 0. Those are your zeros. Okay, let's talk about, so those are our zeros. Let's talk about our multiplicity. This one has a multiplicity of 2. This one has a multiplicity of 2. So those are both bounces off the 0. Those ones are going to bounce off the 0. This is a multiplicity of 1 and a multiplicity of 1. And so that means the graph, when we go to graph it, should pass through from the positive side to the negative side on both of those zeros. So let's take our quantities here. We have x squared, and then we have x minus 3 squared, and then x plus 4, and 2 minus x. And let's put those on our sign diagram. So our zeros in order, negative 4, 0, 2, and 3. Okay, so here are our different sections of the graph, or the number line, the interval, the domain, right? So x squared equals 0 when x equals 0. And remember, doesn't matter, if I square a value, it's always going to be positive. So don't forget that. That's something that you need to pay attention to. This one's also a quantity squared. Its 0 is 3. Otherwise, it doesn't matter what you plug in. A negative squared is positive, and a positive squared is positive. Now here we have x minus 4. Its 0 is negative 4, and it's x to the first power, so to the left, that's a positive coefficient, so to the left is positive, and to the right is negative. Now here's the last one. Our 0 for 2 minus x is 0, right? But look at the coefficient of x. That's a horizontal flip. It's a negative x, right? So that's going to reverse the signs, right? If I were to plug in a negative 5, 2 minus negative 5, that's positive 7, right? If I plug in a 4, 2 minus 4 is negative 2. So you can see that produces a negative. And so you just have to be on the alert that you have a horizontal reflection there because it's a negative on your x. So now let's count zeros, or multiply negatives. So this one has one negative, so that interval there is negative. And then this interval here is positive, because all positives. Between 0 and 2, it's all positives. Between 2 and 3, it's negative. Positive times positive times positive times negative. And positive times positive times positive times negative is negative. So here we are below. Here we are above. Here we are above. Here we are below. Here we are below. So I see a bounce happening here because we're coming from above, hitting the 0, and then going back up. And then between 2 and 3, at 3, at x equals 2, we're coming up from below, bouncing off the 3, and then going back down. So what are we going to do about that? Let's graph that. And our y-intercept is 0 in this case because we have a 0 at 0. So what does this graph look like? We're not going to put a scale on our y-axis. So we have a 0 out here at negative 4, and then at 0, and at 2, and at 3. So those are our zeros. So we're going to start on this side of negative 4 below the graph, and then we're going to go above the graph and come back down to 0. So it's going to go like this: below, above, come back down to 0, bounce off 0 because we have to go, it has to be between 0 and 2. I still have to be at positive value, and then I come back down to 2, and between 2 and 3 I'm below the graph, and then I hit 3, and then I have to come back below the graph. So it's doing something like that, which is pretty crazy looking, I think. All right, so now we just have to answer the question, when is f of x greater than 0? That happens in the intervals here where we have positive outputs here. So that would be between negative 4 and 0, and 0 and 2. And our f of x, our y's will be less than 0 or negative between negative, this here section and this section and this section, those three sections. You can see it here, here, and here as well. Negative infinity to negative 4, union 2 to 3, union 3 to infinity. And that's how you use a sign diagram and factors and multiplicity just to sketch a graph. It's not perfection. Again, you can go in Desmos and you can double check your graph to see if it's right. But what I'm going to be looking for in your homework is your sign diagrams and your sketches. So make sure that you're not trying to use Desmos to support everything, because we're building this skill. This is an important skill. We're building that skill. Important. Okay? All right. On the example 2, it says sketch the graph of the polynomial given the sign diagram. So the sign diagram's already filled out. It's telling you here you're going to be below the graph, here you're going to be above, then below, then above, then below. So you take your number line, and let's see, you put 0, you put your y-axis there. So at -2 and -1, 1, 2, 3, 4. At 1.5 you have a 0, and at 4 you have a 0. So you have zeros in these 4 spots, and between -infinity and 2 you're below. So you're coming from below, and then between -2 and -1 you're above. Then between -1 and 1.5 you're below, and then between 1.5 and 4 you're above, and then you have to curve back down after 4 and be below. So that would be a diagram for that one. There you go. So you give the next one a go, and let's see how you do. So on the left you're above, between 0 and 1 you're below, between 1 and 3 you're below, between 3 and 5 you're above, and after 5 you're above. And so you've got a couple bounces here, right? So that must have a multiplicity of 2. Now if I was writing this equation, it would probably look something like this. Because my graph is opening up on both ends, my a is going to be positive. I don't know what it is, but I do know this. It has x equals 0, so that's that term. And this is x plus 1, and that's going to be quantity squared because there's a bounce there. And at 5, there's also a bounce. So my next term would be x minus 3 to the first power, because there's no bounce at x equals 3, it passes through. And then x minus 5, quantity squared, because of the bounce here. And so I will be soon teaching you how to write those equations, by the way. All right, on to the next one. Now this one's a little bit more tricky. It says sketch a graph of f of x equals x minus a times x minus b times x minus c, where c is less than a, is less than 0, is less than b. So that means that c is negative, a is negative, and b is positive. So what I like to do with these problems when I'm given these kind of abstract problems is I just like to pick values that are actually true. So -3 is less than -1 is less than 0 is less than maybe 4 or something like that. So you could pick values to help you like work yourself through the problem. All right, so we're going to sketch a graph of this. So here's what I know. I'm going to go ahead and I'm going to sketch. Here's C. So C's 0 is -3. Okay, it's -3, and A is -2. Wait a second, let me double check my math. I think I'm not thinking here. Let me write it out. Let me write it out like this. So it would be x minus A, that's what it would look like, times x minus C, so that would be a -3, times x minus b if b was 4. And so that would be plus, and that would be plus, and that would be minus. So I would do this. X, I don't know why I did the b first. I could have done the c first. But so that would be x plus b times x plus c times x minus a, right? Because we're doing opposites there. And so that's what the factors would look like, and that's kind of tricky. So let me get those graphed there. So this would be C, and this would be A, B, and this would be, no, this is A, sorry. Here's 0, and then here's B. And here are our factors, x plus B, x plus C, and x minus A. And again, I was just using that format, and then I was kind of using my numbers that I'd chosen for C, A, and B to help me figure out how to write those factors out, right? If it's negative, oh my goodness, this is A, and this is B. I apologize. This is my A, because I chose A as -1, and that's my B. So let me fix that. All right, so let's back that up, because I want to make sure you have good information. So again, we picked -3 for C, just to indicate some values, -1 and 4. And then we're using this format to fill it out. So I'm going to do this in the correct order. So we're doing x minus A, right? So minus -1 times x minus -3. Oh no, let me do the B, x minus B, so that would be x minus 4 times x minus C. Okay, so I can do this, and I can do that. And so here are my values. X plus 1, so I'm going to write that as x plus A. X minus 4, so that would be x minus 4, which would be x minus B, and then x plus 3, right? X plus 3, so that would be x plus C. So again, I was just using those numbers to help me write out my factors. All right, so I have them stacked over here, and my zeros, these are my zeros. So B is the 0 for negative B, and since my x is positive, negative, 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 positive. And my C, there's my 0 here, negative, positive, 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 and then A's 0 is here, negative, negative, positive, positive, right? Okay, so left of negative C, or left of C, you get a negative output, so that's below. In between C and A, you get a positive output, that's above. Between A and B, where 0 exists, you have a negative output, so that's below. And then after B, you have a positive, and so that would be above. And so if I had to sketch that graph, I'm going to move this out of the way a little bit. It would look something like this. All right, so here is C, here is A, and here is B somewhere. And between negative infinity and C, I'm below. Between C and A, I'm above. Between A and B, I'm below. And after B, I'm above. So the graph is doing something like that. Something like that. All right. Now, what is the y-intercept? Okay, so the y-intercept is this. The y-intercept is when you plug in 0 for x. So that would be 0 plus A. Sorry, this is your y-intercept. Y-intercept is when x equals 0. 0 minus B times 0 plus C. So that would be A times negative B times C. And so your y-intercept would be negative A, B, C. So that would be this point right here. Negative A times B times C. That would be your y-intercept. So your y-intercept is negative A, B, C, 0. And what is the solution to your f of x is greater than 0? So your f of x is greater than 0 when you are above the x-axis. So that would be in the interval between c and a, and the interval between b and infinity. Okay, now be careful here. This is f of x is greater than or equal to 0. So you know that means include the zeros this time. So when I'm above or when I'm at 0. So I'm above, f of x is greater than or equal to 0 from here to here between, oh my goodness, I'm going to have some ginkgo biloba or something. My brain is not focusing. This says less than 0. So that means I'm picking the below sections. My goodness. All right. So that would be from negative infinity to c union a to b. That's when we're below. We're greater than or equal to 0. So that means we include the zeros between c and a and from b to infinity. And we would use closed intervals because we're actually including the zeros because of the equal sign. And there you go. So that's what you're going to be working on for homework today. So please make sure you understand how to use a sign diagram and that you remember how to factor. And good luck. Have a good one.